Hello world, welcome to Learning Electronic Repairs. This is my first video, so I will apologise now, as never done anything like this before, but I thought I would give it a go. I'm not fully versed on electronics, but thought I would take the plunge and give it a shot. Always had a keen interest and thought, why not give it a go? And as you can see, I have already bought some equipment. This is the first video, an unboxing video. This has been purchased from an online retailer, AliExpress, and we thought it is something that I would need. Not sure if anyone can guess what it's going to be. Slowly reveal, and some people might recognise the brand. Found this online and seen lots of other reviews of it online as well, so thought it might be a nice thing to do a video on and practice my technique. It's a Owon smart tester, if that's how it's pronounced, and it's a digital multimeter. So in the box, it comes all the way over from China. We can see what we get. Nice packaging. We get the main unit, which cellophane wrap. Cheap plastic cellophane, can't say I'm too keen on that. Nice bag of test leads, again, they'll do. And then we get some other bits and bobs. So we'll just get this out of the way and we'll run through what we have. Not sure if the audio on this will be okay, guys and gals, as it's only recording off my internal microphone on my webcam. We have a selection of different cables. Just unwrapping these. This is a USB, like a printer. I think it's USB B or USB A, and that's USB A, and that looks like just USB 2 speeds from the look in the plug. We have what looks to be a USB power cable there, a couple of clips for the probes, which are here, which I would say are about 1 meter long or 3 feet for our Imperial colleagues. Not particularly sharp. They'll puncture some things, but I'm pushing quite hard there with no issue. And some little caps. Probably pretty much what you'd expect from included budget prongs. You get your little clips on. Again, I'm not sure whether you can see inside of there. Getting used to the camera, but there is a little adapter in there which will reciprocate the prong, so I can use it as a clip, as you can see. Quite a lot of tension on that as well to enable us to clip straight on and hold a ground, for example, rather than having to use 2 test probes. So not bad, not brilliant. The rated Cat 3, 1000 volt max at 10 amp. Pretty much standard, run of the mill, what I would imagine you get in a lot. This was my old meter that I've had a lot of years, and to be honest, I'm running very similar quality probes. These are 20 amp, not that I ever get anywhere near that. Use it for simple voltage testing, continuity, diode, capacitance. Never really use the ampage function, so the 10 or 20 amp will be fine. We will test the resistance of these cables. I would imagine they were going to be pretty poor, but we know what we're working with on that. Instructions wise, for the ones who like to read books, we have a nice data sheet, if that can be seen, and I'm sure if the resolution on my terrible webcam is anywhere near good enough, you can have a look at that. It's quoting DC voltage measurements from 50 millivolts up to 1000 volts with an accuracy of 0.01% plus 10. An AC voltage of 500 millivolts to 750 volts. DC current testing from 500 microvolts to 10 amps. A AC current from 500 microvolts to 500 milliamps. Sorry, 500 microamps to 500 milliamps, and then a range between 5 amps and 10 amps. And 20 hertz to 1 kilohertz range. Resistance 500 ohms to 50 mega ohms. Diode 3 volts. Continuity 1000 ohms with an adjustable threshold. That might be useful if we're using the beep continuity for testing for shorts. We can adjust that to trigger a lower sensitivity or a higher sensitivity, so we're not getting false positives. Frequency 10 hertz to 60 megahertz. Capacitance 50 nanofarads to 500 microfarads, and 5 mF, not sure what that is, to 500 mF. Are they millifarads? I'm sure somebody will tell me in chat. Temperature is -200 to 1300 C, so typical British summer. And a PT100 temperature, again not sure what that is, -200 to 800 C. That's a cool day in the UK. Display counts is 55,000, and it record intervals at 15 milliseconds to 999,000 seconds, and a record length of 1000 points. I did see on one of the other videos that you could record capacitance value on unit and also resistance value. So if you were checking multiple components on a single circuit, for example, and you wanted to compare from board to board, you could just store one and then go to the other board without needing to write it down. Whether that'll be useful at this stage in my learning journey, not too sure, but we'll give it a go. It's a 3.5-inch TFT LCD screen with an operating temperature of 0 to 50 degrees. The interface is R3232 or USB. I bought this specifically because I understand it'll run on USB with the software you can download, so I can bring it on screen when I start doing more testing. 30-minute warm-up time. Not sure what that means, which is a bit strange. We're having a warm-up time of here, but yeah. And then the weight is just under 0.5 kilo, dimensions are in millimeters, so 200 by 87 by 65, or 20 centimeters by 87 centimeters by 6.5 centimeters. What that is in imperial is probably around 9 inches, 10 inches by 3 inches by probably 4 and a bit inches. So that's the spec sheet. The operating guide seems pretty comprehensive. Some safety terms, not to electrocutors, can't guarantee that won't happen. It's got 4 ports on the front, which I'll run through in a minute, and so on. So nice little booklet for people to read, and it says we get a spare fuse enclosed and a power cord. Well, that's completely wrong, we don't get that. So, oh, this is when it's just the AC version, and I've gone for the battery backup version. So, without any further ado, why don't we get it open and turn it on and see where we go. It's like Christmas all over again. There we go. And we have a screen peel, and I'm sure we will be liking that. I will figure out a way to flip the video at some point so you guys can see what I see. At the moment, with it being the first video, I'm still practicing. So we'll press the power button and it loads. Loading time well, about 2.5 seconds, something like that. So that's not too bad at all. We have a selection of buttons on the front. Again, let's turn it around so you guys can see it the right way. We have volts DC, I'm looking at this upside down, and AC, ampage, AC DC, capacitance, frequency, temperature. This will be ohms, continuity and diode. Then we've got a selection of other buttons here, which I am not sure what they do, but at the moment I think it'll be volts, capacitance, and then resistance, diode and beeping, continuity. It looks like we can do a different response time for low, medium and high responses, and we'll give that a shot in a second. And we have another button there. 10 amp current, that's your 600 milliamp, and then we've got common and your positive voltage line up to 1000 volts. Along the back we have 5 volt DC input, USB type C, which is what we'll be powering it from, and a USB for the display. So it is 5 volts, so we will grab the 5 volt adapter. Because I'm very well organised, I have everything to hand. We'll plug this in my tester, and this should enable us to read what current draw we are getting. Okay, so it is pulling 5 volts and 400 milliamps, so just under half an amp on there, and that is with it turned on. Let's turn it off. It is now powered off, and it doesn't charge whilst it's off, which is interesting. Let's turn it back on. Unit is powering up, and as you can see, it's now pulling current again. Let's just turn it off. It is pulling the same current on or off, so it is just a charge cycle it's going in. So we'll turn it on. Nice reassuring click of something inside. I would imagine that's some type of relay. You can take this out because by the looks of it, the battery is fully charged, which is up there. Take that out. I'm going to attempt to zoom in so we can see a little bit closer. There we go. Reasonably sturdy feet. Not sure whether we'd get away with pressing any of the top buttons without it falling. It's a bit, I am being able to do it, but it is rocking. Certainly the lower down the buttons I'm going, the easier it becomes. So let's get our included probes plugged in and see where we go. They go in quite a distance, so let's uncouple and let's figure out how to get this to resistance mode. So now it's auto ranging, which is down here, which is on the 50. And it's reading 0.45. And then we can zero that out there, which is always a nice little feature. Back on. Rocking up and down. Let's change the speed to high. And we can see it does that. And let's see if we can get the range from auto to let's go to 5k. So we can see it changes the thing there. Let's change this again and pop it on beep mode. And for the moment, the beeper is off. So we'll turn that. Oh, that's where we can change it to 0.5 volt. That's on diode test, sorry. Ohms. Diode, resistance, continuity. So let's see if we can. It is a bit slow to respond, as you can see. So it's not the fastest at doing it. It looks like we can change the threshold. Really not sure how to do that. It does connect to a PC, so we can, here we go. So we've got a range thing here. So that now triggers a lower voltage in diode. Resistance, continuity, This is changing where the ohmage will go through. Yeah. That's good. So that's done on there. We do have a math button, but no idea what that's for. Let's go to System, version 4.4. Next. And let's leave that on, powering on to the last screen. That might be useful. We've got a clock if we want to set the time, which is not the time now, but we do that at some other stage. And we have a reset. So I'm hoping, yeah, the reset has obviously reset it. So that's really it at the moment, guys. Thank you very much for watching. Again, this is my first video, so I don't think it's polished, but I will give it a shot. The intent is to start diagnosing and working on simple electronics that I've begged, borrowed and stolen. Only joking. Begged and borrowed or bought on eBay. And finding a way forward on our journey. There might be some white smoke. There might be some electrocution. There might be some bangs and pops, but let's do it together. Thank you very much. See you all soon.